Hi, good morning, and welcome to the ZP webinar. We do this kind of webinar every Sunday at 8 a.m. And we have a look back at the news for this week. So I just want to say hi to Aftab, who's come on really early this week. So nice to see you, Aftab. And I'll try and highlight some news that might be kind of interesting and relevant to you guys. So let me just jump straight into it. And I think this will be sort of interesting. You know, people often ask us, you know, how long do CGMs or continuous glucose monitoring actually run for? The reason that CGM, you have sort of, you know, transdermal CGM where the sensor goes through the skin and into the interstitial fluid. Those kind of sensors, what stops them running for an awfully long time is really the immune response. They get biofouled, you know, proteins and cells get deposited around the sensor and it blocks the sensor. Now there's another type of sensor then, which is the needle type of sensor. These are sort of transdermal, and there's not a transdermal needle sensor on the market. There's only academic work at the moment. Now the reason I was sort of slightly talking about that was because Aftab is online today. We get a lot of inquiries from across the globe, including a lot from India. And so I just wanted to highlight that on our news sort of channel this week, we put out that, you know, these glucose sensors that we have, you know, they last for like, you know, over 125 days. Hi, Ali, nice to see you. Now, the reason that these sensors last over 125 days is because what stops sensors working in the body is very rarely the sensor itself. It's actually the biofouling encapsulation that I mentioned earlier on. So I just wanted to kind of highlight that, you know, we've been continually running a sensor for over 125 days. If you're watching the video version of this, you'll see that we have little dips in the current that I've like highlighted with arrows, and those little dips are when we essentially put the sensor into 0 millimolar glucose just to make sure that the sensor's still operating. So you can see that what I want to say is, you know, glucose sensors are not intrinsically have short lives. The enzymes are actually really quite robust. It's actually the sort of the biology of putting these sensors into humans or into animals that ends up fouling the sensors that shortens the life. But here's some good evidence that you can continually monitor a glucose solution for something like 125 days. And at this point, this sensor is probably still running and probably still going quite strong. I would have at this point really not much of a concern to say that a well-constructed glucose sensor in an in vitro experiment could probably run for, you know, a year. But when I have the data, then I will essentially share it with you guys. So that was the first bit of news this week, that we just put some data out there of a very long experiment where we've been running for days and days. And I suppose that's a sort of, you know, it tells you what our labs must be like, that you can set up these experiments and, you know, you can just leave them running for that kind of length of time. Now, I know that Ali and Aftab have seen this already, but we did sort of do a paper with the University of Swansea that was published this week, and in that paper they were using kind of screen printed graphene electrodes and also pH electrodes, and essentially it's recognized in our products that we do have a really good screen printed pH sensor. I know Ali in particular has an interest in water monitoring, so Ali, you know, we have this version of our pH sensor. You know, I know it still seems expensive, but we're selling 10 sensors at like 20 euros each. And it's just to make the point really that, you know, you can make these kind of screen printed electrodes very low cost. And then when we do the higher volumes, I believe if I remember rightly, that we're doing electrodes for much less than, you know, 20 euros each. So I'm a big believer that eventually we'll get to a point where a lot of water testing, a lot of environmental testing is done on these kind of low cost type of screen printed electrodes. Now, the reason, as I say, I was talking about these pH ones is because we did the paper with Swansea University. But it's also probably just worth saying that I'm really quite excited by this, to be frank. And I'd be very interested in people's thoughts and comments around this, because we've also made a graphene electrode now. And it's kind of, I think it's the lowest cost graphene electrode on the market, but of course I don't always know what other people's pricing are, but I know that, the fact that I think this is a fairly low cost graphene electrode, so I would be super interested in, if this is not the lowest cost graphene electrode in the world, then I'd be super interested to know what it is. For me, the reason that we've made this kind of graphene screen printed electrode is because people want it, but it's also to prove the point that this stuff can be low cost. And so we did it. So a couple of things. We did a paper with Swansea University this week. We've also, as a derivative of that, we have our pH sensor now, and we also have our graphene screen printed electrode. So happy to have done the collaboration, and happy to have these products that reflect the collaboration. Now, I have already mentioned it, but I think it's just interesting to know about this kind of thing. If you're following along on the video at the moment, that's interesting to know. Aftab just said that in his knowledge it is low cost, the graphene electrode, so that's good. Now, the reason I'm showing this particular photo, if you're filming the video, it's a picture of Birgitta and Evan. So Evan is the Evan Zimmer in Zimmer and Peacock, and this is Birgitta, one of our lead biologists. It's an unusual business, actually, that we do have, scientific disciplines involve at least a biologist. We must have some biochemists, material scientists, chemists, and then obviously electrochemists as well. So Birgitta is one of our biologists. Evan and her were at a conference in Norway called TECMA, and TECMA, I think a literal translation would be like Technology C. So I know I've said it before, but we're very interested in the sensors for the salmon farming. Sort of fish farming is an important source of protein in the world. And at Zimmer and Peacock, we're developing a glucose sensor and a cortisol sensor for measuring those analytes in the fish. So I know that Ali and Aftab have seen these types of videos before, but it's really coming on now. The cortisol sensor is becoming very much more sensitive. I think we're down at, I want to be ridiculous and say that we're lower than 1 nanomolar now in terms of sensitivity on the cortisol sensor, so it's getting really quite robust. And these sensors, the initial driver is to get them into fish, but obviously the sensor doesn't mind where it goes in the end, so that's just the sort of starting point for us. So I was grateful for Birgitta and Evan for going to TECMA, and they presented our technology at that conference. We did have our usual ZP Developer Zone webinar this week. It was kind of an interesting one because obviously, we were talking about measuring glucose in the sweat, which was really the main topic of conversation this week. And it was interesting because from the conversation, it kind of, we were talking about whether there's really a good correlation between glucose in the blood and glucose in the sweat, and we were all discussing that it's a hard one to actually say that there is a good correlation. And so the gentleman who was asking the question said live, well, what would you recommend? And we sort of said, well, maybe microneedles would be the direction to go in, but we'll sort of see from there. But that's the nice thing about, I would say, the ZP Developer Zone, that is actually quite interactive, and we'll get some really good comments from people like Ali and Aftab who are online with us today, so I appreciate that. Now, this might actually be very interesting, particularly to Aftab, So at Zimmer and Peacock, we have a database called Julie. We are at the moment the biggest users of Julie. Julie allows us to upload our electrochemical data, analyze our electrochemical data, share our electrochemical data. And I've always been interested in obviously making Julie smart by bringing sort of AI capabilities, artificial intelligence capabilities into Julie and doing data classification. Now what we've done is we've expanded Julie now to actually be able to receive images. You can actually Julie's becoming much more, let's say, like an electronic lab notebook, and but we've also expanded it because we have a particular sort of client of it who is interested in this, that we now have an app, and the app is essentially a conduit to Julie. It can bring data into Julie, and this app has a very specific function. It's meant to actually take pictures of, it sounds crazy, but cookies or biscuits, depending on where you are in the world. And what you do is you take a picture of the cookie or the biscuit and you classify it as cooked, overcooked, or undercooked. At which point now the image goes to Julie and you're essentially training it. I mean, I think both of you, Ali and Aftab, will get this. This is essentially, we're tagging the data, or the user is tagging the data, and the database is essentially looking at these tags, looking at the images, and is then able to start learning how to classify whether the cookie is burnt or all perfect, let's say. So that's something that's slightly unusual. And now I bring it up especially to Ali and Aftab who are online, because I'm really thinking about other applications that we can use Julie for. I mean, just as a comment, guys, I'm just going to grab a lateral flow strip that I actually happen to have on my desk here. And so I was kind of been thinking to myself, well, actually we can use this kind of image recognition, image classification to start working on, classifying colorimetric assays. So Zimmer and Peacock, we're an electrochemistry business. As we develop our technologies like this image classification for Julie, it would allow us to become involved in things like colorimetric assays, maybe lateral flow assays. So at the moment, if you do a lateral flow strip, there's no way of digitizing the signal. But of course, if you take a picture and you upload it to something like Julie, then we can actually do image classification on this. So Aftab is just sort of agreeing with this as well, because I know Aftab has a kind of a background and an interest in this kind of thing. So I went slightly off on a tangent there, but I'll bring it back a bit and sort of say, at Zimmer and Peacock, the news is, we have Julie. It is powerful. It's getting powerfuler. We are using it a lot. We actually have a client now who wanted us to come up with a way of allowing them to determine in their factory whether they were preparing the cookies correctly. And so we made a app that runs on the front end of Julie. You can take a picture of the biscuit and you can start training the database. You're right, it's machine learning. And I am interested in expanding this kind of image capture. You can use it in crops, you could use it in maybe looking at the clarity of water. I'm just kind of thinking aloud a little bit, but anything where the data is an image or a color, we could start rolling it out to applications, let's say, like that. All right, I'll roll back a bit now and carry on with our news. And I think I'm coming to the last bit of the news now. I think this is actually quite interesting. Right, so at Zimmer and Peacock, like other companies, we do thick film printing, for example, and I'll use gold as the example. So we do thick film printing of gold. We make some nice gold screen printed electrodes. Great, love those. We also do some vapor deposition of gold, and they make for really nice gold electrodes as well. And I might just kind of touch on that just very quickly on the video. So we do have those nice screen printed gold electrodes. They work, to be frank, really well. The guys know this, that the biggest consumer of ZP screen printed gold electrodes is Zimmer and Peacock, and so they have to be good because we have to use them day in, day out. And then over the years, we've expanded our capability, and we make quite a nice sputtered gold electrode these days. I'm even quite interested in some of these sputtered gold electrodes because we put these little wells onto the electrode, and they're quite good for people who want to do kind of spot testing or discrete testing of samples. We've got this little vessel that sits on the electrodes, and you can put your kind of sample into there. So, and that's on a sputtered electrode. So we have screen printed electrodes, sputtered electrodes, and the reason I'm kind of listing that out is because we have a sister company called Massier Sensors. You'll see them on LinkedIn, and you'll see them around the web. And what they've just done is, I think this is really quite good. They've just made gold electrodes from PCB, from printed circuit board. Now, before you go, that's been done before. I know it's been done. Zimmer and Peacock has done it. I've worked with companies that have done it in commercially as well. But what people don't tell you a lot of, and I do talk about it, is actually PCBs corrode. So if you do ever Google like corrosion, PCB, electrodes, Zimmer and Peacock, if you Google those kind of words together, you'll find some evidence from our website that these electrodes corrode. Underneath the printed circuit board gold, there's there could be chromium or nickel, there could be some copper around that they basically corrode. So the reason I'm talking about all of this is we put an image up this week where we show normal gold used as an electrode, and it shows some very odd shapes, and it's essentially because the liquid has got through the gold and is having a corrosion with the underlying materials. So it says if you use normal PCB gold as your electrode, it's not that robust. But our sister company Massier Sensors, they visited our labs, and they've developed this process where they actually make a much more robust, much more I want to say almost perfect electrode. And I'm just looking at the data online at the moment, and I almost feel like the peak separation is pretty. It's not 57 millivolt peak to peak separation, but it's not bad. It's about it's a couple of hundred, but it's not bad. And what I want to say here is, yes, there is a big interest in using PCBs as electrodes. There's actually a bit of a problem that people don't talk about, but if you want to find out about the problem, just Google Zimmer and Peacock corrosion PCBs, and you'll soon find it. But I would say that the sister company Massier Sensors have actually solved this problem by basically coming up with a much better PCB for biosensors. So just an FYI, and hopefully next week then we'll start putting these things onto our web store so that people can benefit from it as well. So there we are. Let me do a summary of what we've talked about. It's kind of interesting when you look at the news from Zimmer and Peacock this week. It's highly technical, in fact. So we put some data out there to say, electrochemical sensors, electrochemical glucose sensors, we've had them running for over 125 days. We put some information out there this week that says, we think we've got the world's lowest cost graphene electrode. I'm really pleased with it. We do a lot of biosensor development, but in fact we sometimes do it for veterinary applications, including fish. I appreciate the guys Aftab and Ali coming along to our ZP Developer Zone on Thursday. There was a really good discussion, and we actually had a live discussion about whether somebody should be trying to measure glucose in sweat. I think this one's particularly interesting to Aftab, that the Julie database that we have actually allows the uploading of images these days, and we can do image classification. And then just finally, I think this is kind of interesting to people like Ali, because he's particularly interested in doing low cost sensors. We have been working on making PCBs more robust so they can actually be used as electrodes in electrochemical biosensors. So I will wrap up now. I appreciate you guys coming online. Appreciate the people who follow us on the ZP Developer Zone. And if you're not a member of the ZP Developer Zone, don't forget it is free to join. So thanks Aftab and thanks Ali. I appreciate it. Well, I'm going to go downstairs and have some coffee and stuff like that now. So I will say thank you very much and speak to some of you very soon. Okay, take care, guys, and thanks for following along with the vlog and the podcast. Take care. Bye-bye.